Dear students, so let's learn more about this particular chapter. In the last class I have explained the different types of the diode which are used for the various application. Using the diode and another semiconductor device which is called transistor, we can design some digital circuits which performs certain logical operation. Basically, there are three types of logical operation: logical addition, logical multiplication, and logical inversion. And to perform these three logical operation, so we have a circuit which we call it as gate. So gate is basically a digital circuit which performs a particular logical operation. And every gate has a certain number of inputs. The minimum is 1, the maximum there can be any number. And across this input, we apply a voltage, either low voltage or high voltage. The applying low voltage is represented by writing a number 0. And the high voltage is normally corresponding to 5 volt is represented by 1. So therefore 0 stands for low voltage and high stands for 5 volt, which is represented by 1. So 1 signifies high voltage and 0 signifies low voltage. And these are considered as input. And there will be one output. So for many inputs there will be only always one output. The output will be either 0 or 1. So in every digital circuit in a gate there will be minimum one input, one or more, and output will be only 1, and it performs certain logical operation. The logical operation, as I mentioned, are logical addition, multiplication, or logical inversion. And all the inputs, what I mean by the number. So A is one input, B is another input, C is one more input. And there are different possibilities are there for these inputs, which can be represented in a table which we call it as a truth table. So the truth table is basically a list of possible inputs and the corresponding output which are represented by Y. So there will be only one output and there can be any number of inputs. So this is about the truth table. So therefore, which are the different gates that we have and then what kind of logical operation which they are going to perform. So that's what we're going to learn. And we're going to begin with a gate which is called OR gate. A OR gate is it's a 2 input logic gate, 2 or more. So minimum 2, maximum again any. So 2 or more input logic gate whose output is high when any one of the input is low. So this should be the condition. So OR gate is a logic gate in which there are 2 or more inputs are there, in which the output is high when either of the input, any one, either A or B is high. Sorry, not A or B is high. Whenever its input is high, not low. So such gate is called as OR gate. So let me repeat, an OR gate is a 2 or more input logic gate whose output is high when any one of the input is high. Okay. So let's represent that in terms of a truth table. So, the simplest OR gate is the one which is having two inputs and Y is the output, and OR gate performs logical addition. So, this is a logical equation, or it is also called as the Boolean equation. So, Boolean equation is one which is normally used to perform logical operation. So, what are the inputs? The inputs are 0 0, 0 1, 1 0, 1 1. So, these are the possible. There are only 4 inputs are possible. If I take more inputs, then we get more possibility. So, according to the definition, a OR gate is a 2 or more input logic gate whose output is high when any one of the input is high. So, here both the inputs are low. So, therefore, the output has to be low only. Now, here in all the 3 cases you get to see at least one of the input is high. So, that is why the output is high. So, this is the kind of the truth table that we get. So, the definition is a OR gate is a logic gate with the 2 or more inputs whose output is high if any one of its input is high. And this is the truth table, and all these are important from the exam point of view. So, they may ask definition, they may ask just truth table, or even there is a logical notation or symbol for every gate, and this is the symbol for the OR gate. So, do remember the symbol is you need to draw a notation like this. These are 2 inputs A and B, and this is the output which is Y, that is equal to A plus B. So, therefore, OR gate performs logical addition. What do you mean by logical addition? Logical addition means output is high when any one of the input is high, and we can design this OR gate with the help of the diodes. So, this is one of the basic gate. The next gate is AND gate, and this AND gate performs logical multiplication. Logical multiplication and algebraic multiplication, there is no difference. So, that is why this is very easy to remember. For example, if there are 2 inputs A and B, 0 0, 0 1, 1 0 and 1 1, and logical multiplication and as algebraic multiplications are the same. So, this is the Boolean equation for the AND gate. So, let us multiply. 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, 1 into 1 is 1. Therefore, this output is completely different from that of the OR gate. So, what is an AND gate? AND gate is a 2 or more input logic gate whose output is high when all the inputs are high, that is when both A and B is high. So, that is why it is named AND gate. So, AND gate performs logical multiplication. So, the definition, AND gate is a logic gate with the 2 or more inputs whose output is high if all the inputs are high, and this is the truth table where we get to see the output is high only when both the inputs are high, and the symbol for the AND gate is different. See, this is the notation for the OR gate. See the symbol for the OR gate and AND gate. So, here instead of the arc it is a straight line. So, this is the notation for the AND gate, and you have to remember these notation because there are some numericals where they will give a simple circuit and then you are asked to find the output, in which you can find the output only if you remember the symbols used for the various gate. So, this is the second gate, which is AND gate. So, therefore, right now we have studied 2 basic gates. One is OR gate which performs a logical addition, and the other is AND gate which performs logical multiplication. And the third basic gate, this is the last, there are only three basic gates are there: AND gate, OR gate, and the next one is NOT gate. NOT gate. In NOT gate, we have only one input. It's a single input logic gate. That means the possibilities are 0 and 1. And the output is the complementary of the input, exactly opposite. That means whenever the voltage is low, the output is high, and whenever the voltage is high at the input, it's exactly low. So this is also called as a inversion gate. It performs a logical inversion. So a NOT gate is a single input logic gate whose output is the complementary of the input, or it performs a logical inversion. NOT gate is a logic gate, one gate with one input whose output is a complement of the input, exactly opposite. It's a single input logic gate, because as I have told you, in logic gate the minimum number of input that is needed is 1, the maximum there can be any number. And this is the truth table for it, and we write y is equal to A inverse. Inverse means it's a complementary. Okay. And the symbol for that is it is similar to that of the diode. You know, this is the symbol for the diode, but for NOT gate we draw that similar symbol, but instead of a vertical line we draw a small circle, which is also called as the bubble. So this bubble signifies the complement or the inversion of a gate. So these are the three basic gates that we have already studied. The gate number 1 is OR gate, which performs a logical addition. The second gate is a AND gate, which performs a logical multiplication, and the third gate is a NOT gate, which performs a logical inversion. In logical addition, the output is high when all the inputs, or sorry, not all, any one of the input is high, and in AND gate the output is high when all the inputs are high, whereas in inversion gate the output is the complement of the input. In the next gate I am going to combine two gates. First I am going to consider the OR gate. Then I will connect this to a NOT gate. So now let us write the Boolean equation. This is A and B. The output here is A plus B, and this is the inversion gate. So therefore the output, final output will be A plus B, the inversion. So let us write the truth table for this: A, B, and then we have A plus B, and then we have A plus B inverse. So 0, 0, 0, 1, 1, 0, 1, 1. This is OR gate. Output is high when any one of the input is high. So therefore it's 0, 1, 1, 1. And when I do the inversion, it is 1 and 0, 0, 0. Therefore, for the kind of the gate that we have designed here, the output is high when all the inputs are low. So an OR gate is with the help of a NOT gate, the output is made complementary, or it's inverted, and such gate is called as NOR gate. So NOR gate is a 2 input or 2 or more inputs logic gate whose output is high when all the inputs are low. So the truth table, so this is the definition: NOR gate is a logic gate with the 2 or more inputs whose output is high if all the inputs are low. So this is the output of the NOR gate. So therefore to design NOR gate we need two basic gates. Which are the two basic gates which are used? One is a OR gate and the other is NOT gate. So therefore if I connect a NOT gate to a OR gate, then we get a NOR gate. What is the logical symbol? It is, see, this is a symbol of the OR gate, similar to that of the OR gate, but we use the complementary symbol or the bubble. So that is the symbol or the notation for the NOR gate. So hope you understood the difference between the symbol of the OR gate and a NOR gate. For a NOR gate, there is an additional inversion symbol or the bubble. So this is this is not the basic gate. This NOR gate is also called as a universal gate. Why it is called universal gate? Because using the NOR gate, we can get all the three basic gates. We can design all the three basic gates with the help of the NOR gate. So, to construct a NOR gate, make use of a OR gate and a NOT gate. So, now I will take AND gate, this is AND, connect this to a NOT gate. This is A, this is B, the output here is A dot B, and now a NOT gate, so which is the inversion of A and B. So let's see the output A and B. This is A dot B, which is the AND gate, and now inversion of it. So possible inputs are 0 0, 0 1, 1 0, and 1 1. So for AND gate, as I have mentioned earlier, make use of the algebraic multiplication. This is 0 0 0 and 1, and now inversion, which is 1 1 1 and 0. So now look at the output. The output is high when any one of the input is low. Output is high when any one, either of the input is low, and such gate is called NAND gate, which is a combination of AND and a NOT gate. So a NAND gate is a two or more input logic gate whose output is high if any one of its input is low. And this is the truth table, and this is the Boolean equation, and then the notation is same as that of the AND gate, similar to that of the AND gate, but with the inversion symbol. Okay. So an AND gate is also called as a universal gate. So total gates that we have learnt is 5, 3 basic gates and 2 universal gates. The 3 basic gates are OR, AND and NOT gate. Then 2 universal gates are NAND gate and NOR gate. Why they are called universal gates? Because using these 2 gates, we can construct the basic gates. Which are the basic? NOT, OR and AND. So hope you have understood all the 5 gates, and normally they ask questions based on these gates, either the symbol or the definition or the truth table, or sometimes they'll ask simple easy problems something like this. So this was a question from the board exam. It's a 1 mark question asked in the exam. So we need to find what is the output of this combination. It's a 1 mark question. So let's first identify what are the gates. So this is AND gate. See, this is the reason why you need to remember the symbol, because the questions of this type is possible, and once you know which is the gate, you can apply the logical operation for every gate. See, without the bubble, it's an OR gate. With the bubble, it's a NOR gate. Here, without the bubble, it's an AND gate. With the bubble, it's a NAND gate. So let's slowly write step by step the output of every gate. For AND gate, it's an gate which performs a logical multiplication. So, multiply 1 into 0 is 0, output of this is 0, and that 0 output of the AND gate is the input to the NAND gate. Then just leave the inversion. OR gate performs what? OR gate performs a logical addition. Logical addition means that the output is high when any one of the input is high. You can see any one of the input is high. So, that is why the output for OR gate I will write here. This is the output for the OR gate. Okay, 1 plus 0 is 1. Now, there is an inversion symbol, right? This is the inversion because it is a NOR gate. So, inversion of 1 will get 0. So, that is the input to the NAND gate. So, now check this gate, it is an AND gate with an inversion. So, for AND gate, apply the Boolean equation. AND gate performs a logical multiplication. So, 0 into 0 is a 0. Now, this is for AND gate. I have written the output for the AND. So, for the NAND, inversion, which is 1. So, therefore, 1 is the answer for this particular diagram. So, hope you have understood. So, that is why there is a need to remember the logical operation, what the logical operation that gate performs, at the same time even the symbol as well. So, study these logic gate part because it is important. There are repeatedly asked questions, the definition of the NOR gate, the NAND gate, they have asked truth table, they have asked the symbol, logical symbol. So, such questions are possible and even questions something like this.